Welcome to another episode of Learning. I thank each one of you for watching my videos and encouraging me. Please like my videos and share them with your friends and colleagues. Please subscribe my channel if you have not already subscribed. Thank you. We continue the discussion of the solutions of the problems that have appeared in the CSIR National Eligibility Test held on February 28, 2025. And today we discuss the solution of a problem from the section Real Analysis, and the problem is related to the concepts of functions of two variables. This question is placed in part C, which is a multiple select question. There can be more than one answer and it carries 4.75 marks. The question ID is 704148. This question is suitable for all these examinations. Right. The given question is, for a positive real number a, square root of a denotes the positive square root of a. Consider the function f from r square to r defined by f of the ordered pair x comma y is equal to x by mod x multiplied by under the square root of x square plus y square when x not equal to 0 and is equal to 0 when x is equal to 0. Which of the following statements are true? We are given four options. Option 1, f is continuous at 0, 0. Option 2, the partial derivatives del f by del x and del f by del y exists at 0, 0. Option 3, f is differentiable at 0, 0. Option 4, f is not differentiable at 0, 0. Right. Let's now discuss the solution of the problem in detail. We have the given function f from r square to r defined like this. First, we discuss the continuity of the given function at 0, 0. For this, I will use epsilon delta definition. Mod of f of x comma y minus f of 0, 0 is equal to modulus of x by mod x multiplied by under the square root of x square plus y square minus f of 0, 0 is 0. And this is equal to mod x by mod x multiplied by under the square root of x square plus y square. We have to take the positive square root only. Right. Mod x modulus of x cancels and you will get under the square root of x square plus y square. Now this is less than epsilon whenever under the square root of x minus 0 whole square plus y minus 0 whole square is less than delta is equal to epsilon. So, given a epsilon greater than 0, there exists a delta which is equal to epsilon greater than 0 such that mod of f of x comma y minus f of 0, 0 is less than epsilon whenever under the square root of x minus 0 whole square plus y minus 0 whole square is less than delta, that is equal to epsilon. This tells us limit the ordered pair x comma y tends to the ordered pair 0 comma 0 of the function f of x comma y is the value of f at 0 comma 0. So the limit exists and is equal to the value of the function f at 0 comma 0. Thus f is continuous at 0 comma 0. Thus the option 1 is true. Right. We continue in the next slide for the discussion of the remaining options. Right. We take option 2. The partial derivatives of del f by del x and del f by del y exist at 0 comma 0. Do they? Right. We find the partial derivative of f with respect to x at 0 comma 0. That is equal to limit h tends to 0 f of 0 plus h comma 0 minus f of 0 comma 0 by h. That's equal to limit h tends to 0 f of h comma 0 minus 0. F of 0 0 is 0 by h. And f of h comma 0. So go to the definition and put x is equal to h and y is equal to 0 and write down. This is equal to limit h tends to 0 h by mod h under the square root of h square plus 0 square by h. So under the square root of h square is modulus of h. So h by mod h into mod h by h. So mod h cancels, h cancels, that will be equal to 1. Thus, the partial derivative of f with respect to x at the origin exists and its value is 1. The partial derivative of f with respect to y at 0 comma 0 is equal to limit k tends to 0 f of 0 comma 0 plus k minus f of 0 0 by k. And that will be limit k tends to 0 f of 0 comma k minus 0 because f of 0 comma 0 is 0. Right, it is here by k. And go to the definition of f of x comma y, put x is equal to 0 and y is equal to k, this is 0. So this will be limit k tends to 0, 0 minus 0 by k, that is 0. Thus, the partial derivatives del f by del x and del f by del y exist at 0 comma 0. The option 2 is also true. We move on to options 3 and 4. So we take option 3, f is differentiable at 0 comma 0. Option 4, f is not differentiable at 0 comma 0. One of them is true. So recall the definition of differentiability in the functions of several variables or functions of two variables. So we have already seen the partial derivative of f with respect to x at the origin is 1. The partial derivative of f with respect to y at origin is 0. Recall the definition of the differentiability in functions of two variables. F is differentiable at 0 comma 0 if and only if limit h comma k tends to 0 comma 0 of f of h comma k minus f of 0 comma 0 minus h of fx at 0 comma 0 minus k of fy at 0 comma 0. Partial derivative with respect to f with respect to y of f at 0 comma 0 by under the square root of h square plus k square. You must be familiar with this kind of a definition, right? So limit hk tends to 0 comma 0 f of hk minus f of 0 0 minus, so f of hk is h by mod h into under the square root of h square plus k square minus f of 0 0 is 0 minus h into f partial derivative of f with respect to x at 0 comma 0 is 1 minus k into partial derivative of f with respect to y at 0 comma 0 is 0. substitute. And this is 0, and you are left with limit hk tends to 0, comma 0, limit h comma k tends to 0, comma 0 of h by mod h under the square root of h square plus k square by under the square root of h square plus k square. They cancel, and we will get h by root h by mod h minus h by under the square root of h square plus k square. Separate them. Limit h tends to 0, h by mod h minus limit h comma k tends to 0, comma 0 of h by under the square root of h square plus k square. Now, as h tends to 0 from left and from right, the h by mod h will take plus 1 and minus 1, which is not unique, therefore limit does not exist. This is a very familiar example. Even this is also a familiar example when we are working out functions of two real variables. Just take let h comma k tends to 0, comma 0 along the path k is equal to mh. If you substitute here, then limit h tends to 0 of h by under the square root of h square plus m square h square, that will be 1 by under the square root of 1 plus m square. This depends on m and varies from path to path, and hence the limit does not exist. In any case, this limit does not exist, right? Because the first limit does not exist, the second limit also does not exist. Therefore, the limit does not exist. So that means f is not differentiable at the origin. So option 3 is not true, option 4 is true. Option 4 is true and option 3 is not true. Right. The answer to this question is option 1, 2 and 4, and that is the detailed discussion of the solution of the given problem from the real analysis, which is related to the concepts of functions of two real variables. Agreed. And I think this is the second question what we are doing from functions of several variables. In all these things, what are they asking? One is continuity at a given point, and computation of partial derivatives, and differentiability at a given point. I think you have to work on the definition of differentiability at a given point and work out some problems. And another important thing is the computation of directional derivatives at a given point. So these are some of the important things, and prepare a good notes and work out some problems, and some previous year question papers you also see. That's all. I am sure that you understood the solution of this problem. Thank you for watching this video now. Please like and share my videos with your friends and colleagues. Please subscribe my channel if you have not already subscribed. I am sure that we are going to meet you once again in another episode of learning. Enjoy learning mathematics. I wish you all the best. Thank you.